good geometry. My head's cut off a little bit because we're a little closer to the whiteboard. But we're talking about arcs and chords for section 11.2. So first things first, this is something we already can figure out probably. A blank is an angle whose vertex is in the center of a circle. So we know that we're going to have some type of angle. So a blank angle is an angle whose vertex is in the center of a circle. So if it's in the center of a circle, it's going to be a central angle. So central angle right here, and then down here, a blank is an unbroken part of the circle consisting of 2 points called the endpoints and the points on all the circle between them. So you can think of this as like a piece of a circumference, and what we're going to call this is an arc. A-R-C, arc. And if we look in this definition table here, a minor arc is an arc whose points are on the interior of a central angle. So it would be this section right here would be our arc, our minor arc. And then our major arc is the arc whose points are on the exterior of a central angle. So the major arc would be all the way around, touching that angle. And if the endpoints lie on a diameter, the arc is a semicircle, which makes sense because if a diameter splits a circle in half, that leaves 180 degrees on both sides, and so that's how much the arc would curve. So that would be a semicircle. And so some measurements. The measurement is going to of the minor arc is just going to be equal to angle x. So the measure of the arc is equal to the measure of angle ABC, which is equal to the measure of angle x. So same thing down here, except this time it would be 360 minus the measure of angle ABC, or we can say 360 minus x degrees, because x is still our central angle here. The measure of a semicircle is equal to 180 degrees, so the measure of EFG equals 180. Simple enough there. So I'll go through this example quick. Please use the table on your notes if you can't see this one very well. As I usually do, just following along with your notes packets, so you can follow along there if you can't see this very well. So for the first example, the first task, we're looking for the measure of angle FMC. So I see F right here, M is the middle, and C is over here. And so we're looking for the angle or the measure of these three sections combined. And so what we can do is we can take the 9%, the 10%, and the 11% and add them all up, and we simply get to FMC. Yeah, okay. Oh, right, okay. So, I'm sorry about that awkward pause. I was confused about the task. So what these percents are telling us is the percent of the total pie that is taking up of the total circle, and in this case, total music sales. So what we can do is multiply that 100% times 360, right, to get it into degrees, or let us work with something. So we're going to take this 9, 10, and 11%, and we're going to get 30%, and 30% of 360 degrees, so 0.3 times 360 is equal to 108. And so that means that the measure of angle FMC equals 108. Yeah, so that's example 1. Example 2, we're looking for the measure of angle AHB. So we're going to start here. AH is over here, and B is all the way over here. So in this case, we're looking for a major arc. because we have a central angle right here, which is 90 degrees, and we're looking for the entire rest of the measurement. And we know that we're looking for an arc because of this sign. We're not looking for an angle like we had in these top and bottom ones. So we're looking for the arc, so we're going to go all the way around. And we know, we don't even have to do any calculations. We know that that's 270 degrees. But what we can do is we can do 0.75 times 360, or we can do, 25 times 360, and then 360 minus that. But either way, it's going to give us 270. And lastly, measure of angle EMD. So EMD is going to be a short little slice, or a small little slice, and it's just going to be found by 0.1 times 360, which is 36. So the answers here are 108 degrees, 270 degrees, and 36 degrees. And that finishes up that example there, and so we'll keep moving on past 11.2 and through 11.3.